2 minutes and we can start the class of 10th standard Cbse numericals. I guess, yeah, very good evening to all the students and welcome to the new delegates, teacher trainees to this class. Very good evening to one and all here. Welcome to Physics Cartoon Camera. And today we will explore some of the numericals of question and answers, how that Cbse asked and how to solve the answer. I guess my voice is very clear to all the teachers and students. And welcoming grand welcome to all the new teachers and renovative scientists and delegates in this forum. Yes, I'll start with the question and answers. Probably last class we have explained few of the questions. We can make a small review, and from today, yes, we can start with the new questions. I guess from here we need to solve quickly. We can solve one by one, and the different parts of the country, the new teachers also joined today. Welcome you all, and the students. We can go ahead with new kinds of numericals today. Yes, I guess from here. My voice is audible to audience. Is it clear? Yes, there is one Cbse question over here. An electric bulb draws a current 0.8 amperes and works on 250 volts on the average 8 hours a day. If energy cost 3 rupees per kilowatt hour, calculate monthly bill for 30 days. So this is the question asked by Cbse, and how to answer this question. In this question we can see that current I 0.8 amperes. Current I 0.8 amperes works on electric potential V is equal to 250 volts on average 8 hours per day. 8 hours per day, let's say time t is equal to 8 hours per day. How many days? 30 days they have given in the question. Now what we need to calculate? Energy we need to calculate. So H value we have to calculate. H refers energy. So the cost of each kilowatt hour is 3 rupees. Okay. Later on we can see the cost. H value how much we have to find out. So as per the formula, H is equal to I square R into T. Okay. Now R value we don't know. I value, V value we know that. While using this R value, we can able to calculate as Ohm's law, V is equal to I into R. R is equal to V by I. So V value 250, I value 0.8, which is 2500 by 8 is the resistance. Now H is equal to I square 0.8 whole square into resistance 2500 by 8 into time t 240 hours. So we will get that H value. Fine. Then that is kilowatt hours. Kilowatt hours we calculated. How many kilowatt hours we are getting? Into 3 rupees is the total cost of the monthly bill. Clear? Next question. Next question. Calculate the resistance of a conductor when the current flowing through it is 0.2 amperes and the potential difference is 0.8 volts. Calculate the resistance of a conductor when the current flowing through it is 0.2 amperes and the potential difference is 0.8 volt. So how to answer this question? Current I is equal to 0.2 amperes. Potential difference V is equal to 0.8 volt. Okay. Now they're asking about resistance R is equal to how much? As you know that V is equal to I into R. R is equal to V by I. So V value 0.8 by 0.2, exactly 4 ohms is the answer. Hope it's clear. Next question. Yes. Next question. When a 12 volt battery is connected across an unknown resistor, 2.5 milliamperes current flows in the circuit. Find the resistance of the resistor. Again repeating. When a 12 volts battery is connected across an unknown resistor, 2.5 milliamperes of the current flowing through circuit. Find the resistance of the resistor. Now given data, V is equal to 12 volts. Current I is equal to 2.5 milliamperes. 2.5 milliamperes we can write 2.5 into 10 power of minus 3 amperes. Find the resistance how much? As you know, V is equal to IR. R is equal to V by I, which is 12 volts by 2.5 into 10 power of minus 3, which is 12 by 2.5 into 10 cube. Okay. If the numerical is very difficult to solve it, just write the units of ohms. Clear? Next question, the Cbse how they asked. The 4 resistors 5 ohms, 10 ohms, 15 ohms and 20 ohms are connected in parallel. Calculate equal resistance. So while in the parallel, the student has to recollect the formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, because they have given 4 resistors. So immediately the formula recollection is important. Now substitute each resistance. So 1 by Rp is equal to 1 by 5 plus 1 by 10 plus 1 by 15 plus 1 by 20. So what is the LCM? Generally, while taking the LCM, students are taking little long time to do that. They are taking some mathematical calculation. Use the number where all the 5, 10, 15, 20 equally multiplied. Let's say that is 60. 5 into 12 plus 10 into 6 plus 15 into 4 plus 20 into 3. As simple. So 12 plus 6, 18. 18 plus 4, 22. 22 plus 3, 25 by 60. Yes, that is 1 by Rp. Rp is equal to, because they are asking equivalent resistance, is equal to 60 by 25. If time is not sufficient to do that, just write that ohms. You will carry the marks. If time is there, simplify further. Alright. Next question. Yes. Next question. Yeah, this is the most important question, frequently asking question. An electric heater is used on 220 volt supply and takes a current of 3.4 amperes. Calculate its power, its resistance when it is in use. So this is one frequently asking question. Now given data, V is equal to 220 volts of the current 3.4 amperes. Calculate its power and calculate its resistance. These two they have asked. As we derived H is equal to I square RT, while in the derivation we got that power P is equal to V into I. So V value 220 into I value 3.4. Fine. So that many watts we will get it. Now again R value we want it. As you know that according to Ohm's law, V is equal to IR, R is equal to V by I. So 220 by 3.4 amperes. So that many ohms we can get it. Dear teachers and students, here I am not solving the numericals completely. I am saying only procedure. I guess you can solve the numericals like simplification methods. So it will take, I want to teach you more number of numericals today. That's what I'm skipping the solvation of the numericals while up to the final answer. I'm giving that formula and substitution. Then remaining answers you can do that easily. Next. This is one of the most important frequently asked question as per my notice. We can see how to answer this question. They given a circuit diagram. Children has to understand very neatly, that is voltage 1.5 into 4. 1.5 into 4 is equal to 6 volts. Clearly they have mentioned. Okay. 6 volts is the battery now. 12 ohms, 18 ohms and 30 ohms of the resistors we connected in parallel. So the first question they are asking, the total effective resistance how much? So total effective resistance, this is under parallel combination. So 1 by Rp is equal to 1 by 12 plus 1 by 18 plus 1 by 30 ohms. Okay. So what is the LCM over here? We have to take LCM. From LCM to Rp value we can take it. And current drawn from the battery, I is equal to V by R. So V value 6 volts by R value, the total resultant resistance in parallel how much we are getting, that we can able to substitute. Now this is the second question. This is the first question. The third question, value of current through each resistor. So as you know, I is equal to V by R. I across 12 ohms how much? I across 18 ohms, I across 30 ohms they are asking. So the common potential V is the same. So 6 volts by 12, again 6 volts by 18, 6 volts by 30. So we can get that different amperes of the current in the parallel circuit. Hope you understood how to answer this question. Next question. The rating of electric heater is 1100 watt 220 volts. Calculate the resistance when it operates at 220 volts. Also calculate energy consumed in kilowatt hours in month of November if the heater is used daily for 4 hours at the rated voltage. So how to answer this? A rate of electric heater 1100 watt. So the given data, power P is equal to 1100 watt of voltage 220 volts. Now calculate resistance they are asking. So power P is equal to V into I. So power P is equal to V into I again V by R. So which implies V square by R. So R is equal to V square by P, which is 220 into 220 by 1100 ohms. How much we are getting? That much. Dear students, if any doubts are there, I'll hold for 30 seconds to 1 minute. You can able to ask any doubt. Very good evening, RNG. I guess you are in Delhi IIT somewhere. Very glad to join here. You are my student of many years and very good relation with the teachers. Finally, you achieved something. Yes, students, if any doubts are there, yes, you can ask me the questions. Any doubts related to the numericals? Feel free to ask. On live itself, I can say the answer to you. Fine. Shall I proceed? If any questions are there, you can post the teachers and the students who are all joined in this class. Next, calculate energy. H is equal to I square R into T. Okay. So R value something we are getting. Again I value we can get I is equal to V by R. That you can substitute. Time T. In the month of November, 30 days. Okay. Daily 4 hours. 30 into 4 is equal to 120 hours. So the values we can able to substitute over here. Then you will get that how much energy. Next. Yeah. This is one of the question I noticed, again the frequently asking question. An air conditioner of the rating 2000 watts 220 volts is operated in a domestic circuit that has the current rating of 5 amperes. So what result do you expect? Which means whether this air conditioner can work with 5 amperes or not. So that is the direct question they are asking. For this, how to answer? Yeah. Now the rate of power P is equal to 2000 watt. voltage 220 volts. Now the current rating they given 5 amperes, but still we can able to calculate current rating. I is equal to V, P is equal to V into I is equal to P by V. P value 2000 by 220, approximately 9 amperes. Now this air conditioner won't work with 5 amperes, it work with 9 amperes. Hope this answer satisfied by the student. Next. Yeah, this is another question. Any doubts? Any doubts up to this numerical? Feel free to ask us. We'll continue. R1 is equal to 10 ohms, R2 is equal to 20 ohms, R3 is equal to 25 ohms, R4 is equal to 5 ohms, and 12 volts battery is connected to the arrangement. Calculate total resistance in the circuit, total current flowing in the circuit. Now you can see R1, R2, R3, R4. Here in this picture you notice that R1, R2, these two are parallel. Again R3, R4 also in parallel. Okay. Now the parallel combination and this parallel combination again under series. So R1 value they have given 10 ohms. R2 value 20 ohms. So both are in parallel. So 1 by R is equal to 1 by R1 plus 1 by R2, which is 20. 2 plus 1 is equal to 3 by 20. So R is equal to 20 by 3, 6.6 ohms. That is in parallel combination. Again these two also again in the parallel. So 1 by R is equal to R3 value 25, R4 value 5 ohms. So 1 by 25 plus 1 by 5. Again take LCM of 25. 1 plus 5 is equal to 6 by 25. R is equal to 25 by 6, which is 4.3, 4.5 something. Yes, approximately. Four ohms, let's consider approximately 4 ohms. Now these two again under series. Let's say this is R A and this is RB something. Both again in series, RA and RB values, which is 6.6 plus 4 is equal to approximately 10.6. Let's say approximately 11 kind of thing. Now total resistance, this is the total resistance, these many ohms. Current I is equal to V by R. So V value 12 by 11, approximately 1.1 amperes. Hope this is clear to you how to solve the question. Next question. Yes, this question before also we have explained. We can calculate individual currents, resistances. So which one is the odd number that we can able to eliminate it? So remaining mean value we can calculate. This is the repeated question. Probably this is also repeated. Yes, we solved. This is repeated. H is equal to I square RT derivation. Yes, I guess this I have explained before. Yes. Huh. This question. The overall resistance of a circuit diagram below 0.5 ohms. Calculate the value of resistance R3. All the three resistors are in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Fine. So total resultant resistance in parallel is 0.5. So 1 by 0.5 is equal to 1 by 2 plus 1 by 2 plus 1 by R3. 1 by 2 plus 1 by 2 is equal to 1. So 1 by 0.5 is equal to 1 plus 1 by R3. 1 by R3 is equal to 1 by 0.5 minus 1. So 1 by R3 is equal to 1 minus 0.5 by 0.5. So exactly 0.5 by 0.5 is equal to 1. So R3 is equal to 1 ohm. So this is the way we need to calculate R3 value. Next. This question. The total resistance between point B and E. Total resistance, the points A and F. So this kind of circuit based questions, yes, they might be asked Cbse board. We can see how to answer this. Now in this picture you can see that A to B 3 ohms, B to C 10 ohms, C to D to, sorry, it's not 10 ohm, 1 ohm, 3 ohm, 1 ohm, 2 ohm and 3 ohm they have connected. And B to E again they connected 3 ohms. E to F 3 ohms. So this is the way the circuit they given. Total resistance between B and E they are asking. So resistance between B and E how much? Let's say 1 ohm, 2 ohm, 3 ohm, all the three resistors end-to-end connection. Yes, all the three resistors end-to-end connection. So which means all the three resistors are in series. So B to C, C to D, D to E all are in series. So total resultant resistance in series 1 plus 2 plus 3 is equal to 6 ohms. Now this total resultant resistance is parallel with 3 ohms. Along BE, okay, 3 ohms is parallel to 6 ohms. Yes or no? So this is the 3 ohm and all the combination we got again 6 ohm. Again these two under the parallel. They're asking about a total resultant resistance between B and E. So 1 by R parallel is equal to 1 by 3 plus 1 by 6. That is equal to 2 plus 1. 3 by 6 is equal to 1 by 2. So R is equal to 2 ohms. So any doubt over here? Any student can send the message, yes sir, again repeat, or any other dialogues. Yes, I can able to answer this question. I can able to answer this question. Any doubts? We will see. Yes, I'll forward again. uh, I guess there is a student, Nitish. Any doubt over here? Shall I proceed? Yes. Now, second question. Total resistance between point A and F. Between these two, what it is? Up to B and E, we got that 2 ohms. Now A and F. A value 3 ohms. Again, this total resultant resistance, we got 2 ohms. Again, turn it here. 3 ohms. A to F. A to F. Again the total resultant resistance they are asking. Now there is series. Again end to end connection. Total resultant resistance in series is equal to 3 ohms plus 2 ohms plus 3 ohms, which is equal to 8 ohms is the answer. So first question answer is 2 ohms. Second question answer is 8 ohms. If you write this is the way, yes, you will get complete 3 marks. Next question. Shortly we'll go for assertion and reasoning questions. Yes. Calculate the effective resistance between P and Q. This type of question also we noticed many times. They given a circuit diagram. Kindly notice over here. P to here 7 ohms, again 3 ohms, and P to Q 1 ohm, and the down one is 6 ohms and 4 ohms. Okay. In this case, what happened? In this case, we need to see that 7 ohm and 3 ohm. 7 ohm and 3 ohm are end-to-end connection. Yes or no? So this end-to-end connection in series. Now I am redrawing that point P to Q up to here. So here 7 ohms and 3 ohms. This point is Q. The top line I mentioned, that is the way. And P to Q directly, which means like this. P to Q, there is a direct connection over here. That is 1 ohm. Again the downwards you can see 6 ohms and 4 ohms. Again that is the downwards of P to Q. Like this you can connect. This is 6 ohms. I am modifying the diagram for your convenience. This is 4 ohms. Now the same diagram I redrawn. This is the way. So what do you mean here? P to Q, the top one is in series, the down line again in series, but the center one 1 ohm is parallel to top also, down also, because all one ends at one terminal, all the other ends at other terminal as per the definition. So here 7 ohms and 3 ohms is equal to resistance in series 7 plus 3, which is 10 ohms. And the downline is 1 ohm. And still downline, that is 6 ohms and 4 ohms. 6 ohms and 4 ohms. Again 10 ohms. So now the top one we got 10 ohms. Again the down resultant resistance is 10 ohms. All the three again in parallel. So 1 by Rp is equal to 1 by 10 plus 1 by 1. Center one is 1 and the down one is 1 by 10. So finally, take LCM of 10. 1 plus 10 here, yes, 10 plus 1, 12 by 10. So Rp is equal to 10 by 12, approximately 0.8 ohms. Hope the students and teachers, hope you understood that how to solve the numerical stepwise. So most of teacher training examinations, they will ask this kind of numerical. Next, any doubt, audience can able to chat with me. Next, yeah, this kind of repeated questions we can skip off. This is both about to in series, the down one in series again will connect in parallel. This is also the same before repeated question. Yes. Now coming to assertion and reasoning questions. So students are much more worried about assertion and reasoning questions, why it's happening, how it is, these things we can discuss. Now assertion and reasoning questions, the question paper will give that 4 options to you. One is both assertion and reason are true and R is the correct explanation of assertion. Second option they'll give both assertion and reasons are true, reason is not correct explanation of assertion. Third option, assertion is true but reason is false. Fourth option, assertion is false but reason is true. These 4 options completely, which is same for all the questions. Now question number 1, assertion. What is assertion? Tungsten metal is used for making filaments of incandescent lamps. That is assertion. They given reason. The melting point of a tungsten is very low. So out of these 4 options, which option we can able to select it, and how we have to select it, why we have to select it? All 4 options, in that one option is correct. Now tungsten metal we are using as incandescent bulbs, that is assertion. What they are saying reason, melting point of tungsten is very low. So what is melting point? This is one doubt. For example, if more current flows, more resistance comes, automatically what happen? Fuse element will be off. The first one is tungsten metal is used for making filaments of incandescent lamps, which is true. But the reason what they're saying, melting point of a tungsten is very low, they're saying. Actually tungsten melting point is high. Bulb should not be, filament should not be off condition. It should not be melt easily. It will take long time to melt. Then only bulb we can able to use it. If simply which is melting, then it is false. So assertion is true, but reason is false. Yes, one of a audience given a right option. Yes, exactly. Now, assertion. If a graph is plotted between potential difference and the current flowing, the graph is a straight line passing through the origin. Straight line passing through the origin, you can able to understand is like a slant. Yes, Basavaraj, I guess you're a teacher. I think so. Yes, you are right. Next, reason. The current is directly proportional to the potential difference. Which one is? Current is directly proportional to potential difference. That is the reason they have given. Assertion they given, if a graph is plotted between potential difference and the current flowing, the graph is a straight line passing through origin. Yes, audience, you can choose your answer. Very fantastic answers by the audience. We can explain why it is. Anyone can choose. Any answer? Correct. Exactly. Well done. Yes, both assertion and reasons are true, and reason is the correct explanation of assertion. Excellent. Now, my doubt is, this is my doubt to the audience. No, yes. My doubt is, audience, once you can reply that, which one is correct? If potential difference increases, current is increasing, or current increases, potential difference is increasing. Which one is right for you? Let's say A and this is B point. Which point is exactly perfect as per the Ohm's law? Once potential difference increases, current is increasing, or current increases, potential difference increasing. Which one is the fact? Uh, yes, but which is exactly correct? Which is exactly correct? Yes, both also fine, because once potential difference increases, current is increasing. Normally we are discussing, but which is what is exactly correct? Sometimes potential difference increases, current may not increase. Second option, if current increases, absolutely potential difference will be increased. This is the fact. As per Ohm's law, yes, we are saying that electric potential increases, current is increasing, but the fact is current increases, potential difference is increasing. This is the fact. Clear? That we can study in higher classes. Yeah. Next. Long wires have greater resistance and smaller wires have lesser resistance. Repeating, assertion here, long wires have the greater resistance and smaller wires having lesser resistance. Now reason, resistance is inversely proportional to the length of the wire. What is the right answer? Obviously, assertion is true. Once length increases, resistance is increasing. If length decreases, resistance is decreasing. That's fine. But the second one they given, resistance is inversely proportional to the length. This is not inversely proportional. It's a directly proportional. So reason is false, but assertion is true. Yes. Next. Next question. Alloys are commonly used in electrical heating devices like electrical, iron, toaster, etc. Reason, alloys do not oxidize readily at higher temperatures. Repeating, alloys are commonly used in electrical heating devices like electrical iron, toasters, etc. Reason they are saying alloys do not oxidize readily at higher temperature. Which one is correct and which one is wrong? Which option we can able to choose it in this kind of questions? Yes, audience, choose your option. Yes, one of audience is saying option B. Option B. The reason behind why that option B, why reason is not correct explanation, what it is correct explanation. When we can say that option A will be correct, what we have to change in the reason? Alloys do not oxidize readily at higher temperatures. What is the meaning over here? Once you can think this kind of question, alloys do not oxidize readily at higher temperature. We need to read very slowly in this kind of questions. Alloys do not oxidize readily at higher temperature. Now the reverse question I'm about to ask. Yes, alloys we are using in electrical heating devices. What purpose alloys we are using? If you give the lowest temperature also, we need to get readily heat. Yes or no? Yes. High melting point. Exactly. Next question. When the resistance are connected end to end consequently, they are said to be in series. When the resistance are connected end to end consecutively, they are said to be in series. Reason they are saying, in case the total resistance is to be increased, then the individual resistance are connected in series. Yes, which option we can able to choose it now? When the resistance are connected in end to end, we are said to be in series. In case the total resistance is to be increased, then the individual resistance are connected in series. Obviously, this is well known question and easy to answer. Very easy to answer. Yes, here wrongly mentioned option A is correct. Option A is correct. Option A is correct. This is wrongly mentioned in this presentation. Option A is the correct answer. Reason is the correct explanation of A. Yes. Once if it is not B, it is A itself. A is the correct explanation. Because the total resistance is increased, then individual resistance are connected in series. Only in series, resultant resistance will be increased. Next. When the resistance are connected between the same 2 points are said to be in parallel. In case the total resistance is to be decreased, then the individual resistance are connected in parallel. The total resultant resistance is to be decreased, then the individual resistance are connected to be parallel. Here also option A is the right answer. Both assertion and reason are true. Option A itself, not B. Yes, this is correct. Because in parallel combination, the total resultant resistance will be lesser than individual resistances. Yes, which is correct. Option assertion they are saying, when the resistance are connected between the same 2 points, which is the meaning of this, are said to be in parallel. So option A is the right answer. Clear? They have given options over in this presentation wrong, but it is yes. Next, a cell is a device which converts chemical energy into electrical energy. Reason, cell maintains a constant potential difference between its terminals for a long time. So which answer we can choose? Cell maintains a constant potential difference between its terminals for a long time. Yes. This option also wrong. This option also wrong. Cell is a device which converts chemical energy to electrical energy. Yes, this is right. Now, cell maintains constant potential difference. Constant potential difference between its terminals for a long time. For a long time. Option A is the right answer, sir, here. Not B. Option A. Because only the battery which can maintain the potential difference. Yes. Only battery can able to maintain the potential difference. So that is the reason. Reason is the correct explanation. But here both are the different actually. Cell is a device which converts chemical energy to electrical energy, and cell is the one of a constant potential difference. Next question. The resistivity of a substance does not depend on the nature of the substance and temperature. The resistance of a substance is characteristic property of a material. First one is false. Resistivity of a substance is depends on the nature of the material. Resistivity depends on the length of a conductor. Resistivity depends on the cross section area. This we studied. So does not depend is wrong. But the second reason which is saying that the resistivity of a substance is the characteristic property of a material, which is true. Assertion is false, but a reason is true. Next. Yes, which is repeated again. Now, a fuse is placed in series with a device. Fuse consists of a piece of wire made up of a metal or an alloy of appropriate melting point. Now, both assertion and reasons are true, but reason is not correct explanation of assertion. Fuse consists of a piece of wire made up of a metal or an alloy of appropriate melting point. Not exactly why we are connected in fuse in series. Okay. This is different and that is different. Now, next assertion. The coil of heater is cut into two equal halves and only one of them is used into heater. The heater will now require half the time to produce the same amount of the heat. Reason, the heat produced is directly proportional to the square of the current. Now, both assertion and reason are true. Reason is not correct explanation of assertion. So many more with assertion and reasonings we will do in the revision. And thank you so much all the participants, teachers, delegates and students. So every day, tomorrow again class 10th standard, magnetic effect of electric current chapter will be begins. And please welcome every day 10 to 11. After class 10th, we'll go ahead for class 11th and class 12th. Alright. So if any doubt is there, in my description there is an email ID. You can able to send questions. Yes, we can able to answer. Thank you so much. Have a great day. Bye for the day. Good night. Jai Hind.